Hi everybody. So this is just a little video to explain about resistance. And before you listen to this recording of mine, you must actually watch that YouTube video with the marbles rolling down a nail board. So the nail board itself stands for the inside of a metal wire, and the nails itself represent the nuclei of the atoms that make the wire. The loose marbles are the free electrons that are free to move. Now, in any wire, these electrons that are free to move, especially in a metal wire, which don't have many valence electrons, the electrons just move at random from all over the place. But the moment the ends of a wire are connected to a battery, there is what we call a potential difference. That means batteries have got two ends, a positive and a negative. So there's more negatives at one end compared to the other. So the electrons experience a force and they all start to move. Now, as they start to move, they collide with the nuclei of the atoms in the wire, and that's what you saw happening to the marbles. Now, if those nuclei, if the nails were not there, there would be nothing restricting the flow of those marbles. Okay, so the slowing down of electrons because of their continual collisions with the nuclei of atoms is called resistance. Okay, and what happens is they lose their kinetic energy, and this kinetic energy is converted to heat. So when any wire has a current going through, if you touch that wire, it's going to feel hot. And that's what resistors do. They convert electrical energy to heat energy. Okay? So that's what resistance is. It's a slowing down of electrons. And the slower they go, the smaller the current. So bigger the resistance, smaller the current. Now, what does resistance depend on? So resistance actually depends on a few things. So it depends on what the material of the wire is. So different sorts of materials have different what we call resistivity. And then it also depends on the length of the wire. So longer a wire, the more the resistance. Okay, and the third thing is broader wires. It's like going through a broad road. It's easy to go through a broad road. So broader wires have less resistance compared to narrow wires. Okay, the narrower a passage or a pathway, the harder it is for electrons to flow. Then the next one is, how is resistance measured? So resistance is measured using a multimeter, and we use the ohm meter function of it. So it is the unit for resistance is called ohms, OHMS, and I have a symbol which I'll show you how it's drawn. And then why is resistance important? Now, resistance is important because the total current that's drawn from the battery depends on what is connected in that circuit, and everything has resistance, so it depends on how the things are connected, and it depends on total resistance. Okay, so one of the things that you have in this question sheet is how do you calculate total resistance. So the total resistance depends on how resistors are connected, and for year 11 you only need to know what's total resistance when something is in series or parallel. So in these two, the total resistance, sorry, I've got the wrong sheet here. Here we go. So the total resistance is 2 ohms plus 3 ohms, which is 5 ohms. And that's a symbol for ohms. And this one, you just add up the numbers, and that's your total resistance. So the formula is total resistance, which is RT, is R1 plus R2. And that's the unit. It's measured in ohms. I'll bring back the other sheet. This is from one of the questions that you had on the question sheet under total resistance. And the question was, which one is the greatest resistance? Which one's the least? So the more resistors you have in series, if they're all the same value, your number C will be the greatest resistance. It adds up to 30 ohms. Now, when you have resistors in parallel, the total resistance decreases, not increases. Okay, because it's easier for the current to flow when there are more pathways. So the least resistance will be number D. That's the smallest resistance. Okay, and then there's one more thing that I wanted to show you, and that is when resistors are connected in parallel, the total resistance will always be less than the least resistance. And one of the questions you had was if you have a 5.5 ohm and a 2.5 ohm resistor connected in parallel, then the total resistance will always be less than the smallest number. Your smallest number is 2.1, so it'll be smaller than 2.1. In year 12, we teach you a formula to calculate the total resistance in parallel, but for year 11, you don't need to know that. And I hope this was useful. Bye for now.